In this tutorial, we will see how to use project planning diagrams to find the early start time, early finish time, late start time, late finish time, slack, and free slack for each activity. The steps of planning a project are as follows. 1. Draw the precedence diagram. That was covered in a prior tutorial. 2. Complete a forwards pass. In this pass, we compute the early start time and early finish time. 3. Complete a reverse pass. In this pass, we compute the late start time and late finish time. 4. Compute the slack for each activity. This is how long an activity can be delayed without delaying the completion of the project. And 5. Compute the free slack for each activity. Free slack is always less than or equal to slack. It is how long an activity can be delayed without delaying any other activity. The best way to see the calculations is with an example. This slide shows a sample project the way this information is typically presented. Activity A takes 5 days and has no predecessors. Note that for our purposes it does not matter if it is 5 days, 5 weeks, 5 months, or 5 years. The only thing we need is for all the units to be the same. Also note that there has to be at least one activity that has no immediate predecessors and that this is where you begin constructing the diagram. Activity B takes 3 days and has A as an immediate predecessor. Activity C takes 8 days and also has A as an immediate predecessor. Activity D takes 4 days and has B as an immediate predecessor. Activity E takes 7 days and has C as an immediate predecessor. Activity F takes 3 days and has both D and E as immediate predecessors. The screen shows the network chart for this example. In a forwards pass, we start at the first activity and move to the last activity. Along the way, we calculate the early start time and early finish time for each activity. For the first activity, we assume it starts on time period 0, so that is the early start time. For any activity, the early finish time is just the early start time plus the completion time. For A, 0 plus 5 equals 5. When there's only one line coming into an activity from the left, as there is here, the early start time for the activity is just the early finish time for the prior activity. So, for B, that is the 5 from A. Early finish time is 5 plus 3 equals 8. Activity C also has one line from the left, so its early start time is also 5 and 5 plus 8 equals 13. Activity D has one line coming from B, so its early start time is 8 and 8 plus 4 equals 12. Activity E has one line coming from C, so its early start time is 13 and 13 plus 7 equals 20. Activity F has 2 lines coming in from the left. When that happens in a forwards pass, you select the largest time. With 12 and 20, the largest is 20 and 20 plus 3 equals 23. That completes the forward pass, so we are ready to start the reverse pass. With that, we start at the last activity and work towards the first activity. For the last activity, we assume that the late start time and late finish time equal the early start time and early finish time. That assumption means that the project will be completed as soon as possible. In a reverse pass, if there is only one line coming into an activity from the right, then the late finish time equals the late start time of the following activity. Since activity F follows E, which has a late start time of 20, the late finish time for E is 20. For all activities, the late start time is just the late finish time minus the completion time. For E, 20 minus 7 equals 13. Activity D has one line coming in from the right from activity F. So, its late finish time is 20, and 20 minus 4 equals 16. Activity C has one line coming in from the right from activity E. So, its late finish time is 13, and 13 minus 8 equals 5. Activity B has one line coming in from the right from activity D. So, its late finish time is 16, and 16 minus 3 equals 13. Activity A has 2 lines coming in from the right, one from activity B and the other from activity C. When there are 2 lines in a reverse pass, you take the smallest late start time. Activity B is 13 and C is 5 and the smallest is 5. For A, 5 minus 5 equals 0. Notice that for the first activity, the late start time equals the early start time and the late finish time equals the early finish time. This will always be the case and is a quick check of your calculations on a reverse pass. We are now ready to calculate slack. There are 2 ways to calculate slack for each activity and they give you exactly the same answer. One is late start time minus early start time. The early is late finish time minus early finish time. Additionally, you can calculate slack in any order. 0 minus 0 equals 0 and 5 minus 5 equals 0. The first activity will always have 0 slack. 13 minus 5 equals 8, and 16 minus 8 equals 8. 16 minus 8 equals 8, and 20 minus 12 equals 8. 20 minus 20 equals 0, and 23 minus 23 equals 0. The last activity will always have 0 slack. 13 minus 13 equals 0, and 20 minus 20 equals 0. 5 minus 5 equals 0, and 13 minus 13 equals 0. Notice the path A, C, E, F. Every activity on this path has 0 slack. There will always be at least one path through the project where each activity has 0 slack. This is called the critical path. Paying close attention to the critical path is the key to project management. This topic is covered in detail in any project management course. Free slack is always less than or equal to slack. That means all activities along the critical path also have 0 free slack. That makes sense. If delaying an activity would delay the project, then it would certainly also delay other activities. For activity B, if we delay its start from 5 to 6, then it is completed on 6 plus 3 equals 9. That delays the start of D, so activity B has no free slack because even a single period delay delays another activity. For activity D, if we delay it its full slack of 8 periods and start on 8 plus 8 equals 16, we finish on 16 plus 4 equals 20. That does not delay F, so activity D has a full 8 periods of free slack. Now here's an example for you to try. The activities, immediate predecessors, and times are shown on the screen. Please note that this uses the same diagram as example number 1, only with different times. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The screen shows the solution after the forwards pass. Check your work before continuing. If you made any mistakes on the forward pass, pause the video and correct your work before continuing. The screen shows the solution after the reverse pass. Check your work before continuing. If you made any mistakes, pause the video and correct your work before continuing. The screen shows the final solution with slack and free slack added. Now, as a brief aside, consider the project shown on the screen. Pause the video and sketch out its diagram. The screen shows the resulting diagram. Notice that there is not one unique starting point. Additionally, there is not a unique ending point. Software and experienced analysts can work this problem as is. However, it can be very difficult for students to not have a single starting and ending point. After all, do you start activity A1 at 0, activity 2, or both? The solution is to add a dummy activity with 0 time to both the beginning and ending of the project. Here the dummy activities are labeled with a DU. With the dummy activity in place, you work the problem in the usual fashion. This is left for interested students. The screen now shows a slightly more complex example for you to try. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The screen shows the resulting diagram. If you did not get this correct, pause the video and rework the problem using the correct diagram. The diagram illustrates an important point that students sometimes overlook. Namely, activities do not have to be in alphabetical order from left to right. In fact, on actual projects, these would have names and not letters. Textbooks just use letters to simplify the diagrams and not to add additional details to the problem. The screen now shows the solution to example number 3. In working this problem, remember that both activities B and C now have multiple lines coming into them from right to left on the reverse pass. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.